Properties of light. We first have to start with the sun, which produces most of the light that we see. The sun is a star made of gas. It's the only star in our solar system. Many explosions happen on the sun that create energy. The explosions are like atomic bombs. This energy, called radiation, travels in all directions, including towards the Earth. Electromagnetic radiation. The sun is so powerful that it creates 7 different kinds of radiation. Some of this radiation is strong, while some of it is weak. All of the different kinds of radiation are organized into something known as the electromagnetic spectrum. Here is a diagram of the electromagnetic spectrum. It is organized from weakest on the left, which starts with radio waves, to strongest on the right, which ends with gamma rays. Visible light, which is in the middle, is a medium-powered type of radiation. However, it is the only radiation that we can actually see. Some other types of radiation include microwaves, infrared radiation, UV or ultraviolet radiation, and X-rays. Here are some pictures of radio waves, or actually what they can cause. Radio waves allow our radios to work and also our TVs to work. You can't see the radio waves though, they're invisible. Microwaves are weak waves that can cook your food while using a microwave. They're also used for cell phones and radar. You can't see them, however, they're invisible. Fire. Fire produces infrared radiation. It's weak waves coming from something that is hot. You can't see them though. You can see the fire itself, but not the infrared radiation. Visible light, the focus of this lesson, is the only radiation you can see. It can come from a light bulb or artificial light source, or something natural like the sun. UV or ultraviolet radiation is strong radiation that can make you tan or even give you cancer. You can't see the UV radiation, but you can see its effects on your skin. X-rays, dangerous radiation that can go through to your bones. You can't see the X-rays. However, they are very harmful. Therefore, we limit our exposure to them and only use them when needed. For example, when going to the dentist's office, they will put a vest on your body to protect it while they take X-rays of your mouth area only. Lastly, we have gamma rays, the most powerful radiation. They're very dangerous and found in a nuclear explosion. So again, the electromagnetic spectrum contains 7 types of radiation that leave the sun. Visible light is the one type of radiation that is medium powered. It's the only type that we can actually see. Now, there are some properties of light as well. Light likes to travel in a straight line unless it hits an object and is interrupted. The following can happen when it hits an object. It can reflect or bounce off. It can transmit or go through the object in a straight line. It can absorb or become part of the object, or it can refract and bend as it enters and also leaves the object. Here are some animations to show you the 4 things light can do when it hits an object. We'll start first with a reflection. Notice as it hits the object, it bounces back in the same angle that it entered. Next, we will have an object the light will transmit through. It goes through the object in a straight line. Next, we have a light that absorbs into an object to become a part of the object. Lastly, we have refraction. The light will hit the object and bend as it goes through. Now, visible light or white light is actually composed of many different colors. We don't usually see these colors, however, until the light refracts or bends, which then allows us to see them. The colors are red, orange, yellow, green, blue, indigo, and violet. An easy way to remember these colors are remembering the name Roy G. Biv. Here is light hitting a prism at an angle and as a result refracting as it goes through or bending. When it refracts or bends, we can see the colors of visible light. Again, they're the color of the rainbows. This is why we see a rainbow. Basically, after it rains, the light refracts or bends while going through the water droplets in the air. When the water droplets disappear, the rainbow will as well. There's a picture of a rainbow. Contains all the colors of visible light. Roy G. Biv. You can also see this using a prism, and as you'll see in class, special glasses you can wear that can also refract the light. Now, how do objects actually get their color? It all depends on what color of light is reflected back to our eye. So let's start with the question, why do we see an apple as the color red? Well, the answer has to do with absorption and reflection of light. So if we have an apple, white light, either from a light bulb or the sun, hits the apple. Now, white light contains all the colors of the rainbow, the Roy G. Biv. Every color is absorbed into the apple, except red, which is reflected back to our eye that makes the apple appear red in color. Basically, here's what's happening. The light hits the apple, or in this case, a red object. Everything is absorbed except the red, which is reflected back to our eye, which makes the apple red to us. Basically, an object is a certain color based on what is absorbed versus what is reflected. Reflected equals the color of the object. Now, we also have objects that are black and objects that are white. If an object is black, all colors of the rainbow or Roy G. Biv are absorbed. Nothing is reflected, resulting in no color to be seen by the eye. Black is actually the absence of color. Everything is absorbed, nothing is reflected. This is why wearing black clothing in the summertime actually makes us a little bit warmer than wearing something like white, because all of the sun's or light is absorbed into the clothing and nothing is reflected off, making it hotter than something that is lighter in color. Something that is white would mean all colors of the rainbow or the Roy G. Biv are reflected. Nothing is absorbed. White means full of color, or the entire all colors of the rainbow. Wearing white would keep you cooler. Also, being on something like the sidewalk instead of the black road or paved driveway would be cooler as well. Here's what's happening with black. Everything is absorbed, nothing is reflected, which means it appears black to our eye, or basically without any color. Here's what's happening with white. Everything is reflected, which means it's full of color, just like white light would be. Thank you for viewing this presentation.